Okay, so we're looking at 2018, question 6. Okay, so it's about a guy doing the discus. Let's write down some things that we know. He's got the discus has a mass of 2.0 kgs, uniform circular motion. The radius 1.2 meters. It's a pretty long arm, is it? 1.2 meters. Anyway, the discus has a velocity 20.4 meters per second. They don't say linear velocity, but because it's meters per second, we're going to go with linear velocity when he releases it. Okay, derive an expression to show the relationship between the radius velocity and angular velocity. Yeah, okay, velocity is just normal. Of angular velocity of an object moving in uniform circular motion. Okay, so the first question has nothing to do with the specific event. So radius velocity and angular velocity. So what are we looking for? Omega or and v, omega or and v. Okay, so we start off by saying that the angle covered by anything in radians is the distance traveled in the circle divided by the radius. Okay, now we also know that angular velocity is radians per second. Okay, so it's angle per time. All right, theta over t. So what I want is to divide this thing by t, so that'll give me omega. Okay, so that is s over or t. All right, but we know that distance divided by time is velocity. Okay, so velocity is just displacement divided by time. So I'm using this in here now, so I can say that omega is v over or. Okay, so angular velocity is linear velocity divided by the radius. Okay, calculate the angular velocity of the discus immediately prior to its release. Okay, so up here we knew that the linear speed was 20.4 meters per second and the distance was, the radius is 1.2 meters, so I can put that in. 20.4 divided by 1.2, 17. And that is radians per second. Okay, rads per second. Calculate the centripetal force acting on the discus just before Ashton releases it. Okay, so remember centripetal force is F is mass times acceleration, and angular acceleration, or acceleration is, or centripetal acceleration is omega, or no, it's not, it's omega squared, or that's what it is. So the force, I can work that out. The force is the mass, 2 kilograms, multiplied by 17 to be squared, multiplied by 1.2, the radius. So 17 squared times 2 times 1.2. That gives me 693.6. That's a force, so it's newtons. In what direction does this force apply? Towards the center of the circle. Okay, so remember, centripetal force is the only real one that exists. Centrifugal force is not a real force, it's a reactionary force to centripetal force. Centripetal force is what's required to keep an object moving in a circle.